Can you see my screen now? Okay. So basically, you have some very basic operation, arithmetic operation in the Python. As you can do anything about act. If you want to have a 10, you can add it. Sorry. Add it. You can subtract it. You can divide it. Again, look with keep the integer part only for this one. And also I can do some modulus. Modulus, that means divide and take only the remainder. Yeah, that's what I want. Alright. Also we can do with the exponent. So with the kind of exponent, I have number 4 here, and I want to square it. So I have put equal to alright. That is exponent here. Right. So I have 16 for this one. And so on. Some of very basic operation you can do. You can do with adding, subtracting, multiplication, division, and modulus and exponent here. Some of very basic operation. And so remember about think about you can divide the two integer and take it out the integer part only. Any fractional part will be lost. That in case that's the case you want to work with this one. Think about that, right? 3. So 16 divided by 3, you have the 5.333, but this one only gives the integer part. That's why you have to find. Right? And also for the remainder operator, use the divide and take the remainder only. I think about the case you have x equal to 11, and you have x modulo 3. What do you think? What's the value I have here? If I have x 11 and I modulo 3, what is the value I got in here? What do you think? The remainder only. 11 divided by 3, what's the remainder? Huh? Number 2.
2. Oh.
Yeah, 11 divided by 3, you have the remainder. And now, remember about the rule of the presidential, because the thing about when we have a lot of operation, we have to follow the rule. Some of them you have to do it first, and some of them you do it later. So remember about this operation here. So whenever we do with this kind of operation, you have to do everything inside the parentheses first, right? And later on you can work with the exponent, and later on you work with the division and multiplication, and remember you work it on the order of the operation here. Now if I have this operation, what do you think? What is the final value I have for this one? Right? You can do it. Try it. If I have this operation, what do you think? What's the value I have? You have to do everything under the parentheses first. Inside the parentheses first, right? Okay, so now let's do it here. About this one, what do you think? I have to do this one first, right? I have to do this one under the parentheses first, right? So now in that one, I do everything with this one here, right? So I do this one. So basically, I rewrite it in the 10 minus 2 times 4 here, right? I put it inside the parentheses. So what I have for this one, right? That means I have 10 minus 8 here. I have 2. Right? So I can rewrite it. I have 15 minus 9 divided by 3 plus 3 exponent of 2. Right? So see, when you do this one again, you have to do the exponent. That's because it has a high priority than multiplication and division. Right? That's why I can rewrite it. 15 minus 9 divided by 3 plus this one 9 here. Right? So now I can do it 15. This one have high priority. Right? That's why I have number 3 here. So I have the 12, verse 9, and 21. So basically, you have to follow the rule when you work with the many operations in the work. So we have to follow the rule of priority. Now we move to the very important concept. It is understanding the modularization. So what is modularization? What is a module? Module is a subunit of program, right? And also code is a subroutine, a procedure, a function, or method. Later on, when you work with the Python, you have seen huge benefit when you break it down the program into the procedure or function here. So basically, to call a module, you have to use a name to invoke the module and causing it to execute. And the modularization is the process. You break it down, the whole program, into the multiple module here. Right? So you can think about you have very huge program, complicated program. You can break it down into the many module or submodule here. And that process they call it the modularization of functional decomposition. That you break it down into multiple smaller program, smaller module here, right? Okay. Now that is definition, and you can see the basically for when you work with the modularization program, you have the main program, right? Main program, or you have the basic or mainline logic program, and it includes in the module. Normally, you have the module header, you have module body, and you have module return statement later on. I will explain it to you what is a module header and module module body and return statement here. So because in the program you need action to call the module, that's why it needs a name, right? So a module name is quite similar to the naming variable. It's quite similar to naming variable. Right? Try to use a meaningful module name here instead of the very the one that you have to guess it. Okay, and module name are followed by the set of parentheses. So again, later on I explain it to you what is it. Now, think about you have the program here. Think about you have the program. We break it down into the submodule. Think about it. Normally you have the program. Think about this one here. You have the program here, and you can break it down into the multiple module. Break it down into multiple module. Therefore, it is a hybrid chart here. And again, for each module, again, you can break it down furthermore. You can break it down furthermore. Totally up to you. And if you think about complicated program, you can totally flexible with the module program. You break it down into the multiple submodule also. So when the main program, every program has the main program. And when you execute program, it execute from main program. So when it's execute from main program, it call to the module. It calls the module here, right? So when the program want to use the module, the action here is a call. You want to use it, yeah, you call the module name, right? So what happened after the call statement here? Program control transfer into the first line of the call module. You can think about this one here. This is you can think simple, right? You can think about this is the main program. Is the main. I think about this one is main. And that is the module number 1, number 2, and number 3, and so on here. Right? Now I want to call for the module number 1. What happened here? When I use the call statement here, what action? It will jump to the submodule. It will jump to the submodule. It's the first line of submodule. It executes every statement from the first line to the last statement in the submodule. And it will, after the last statement is a submodule, if you go back to the main module and you move to the next statement of the main module. Right? Now I can do very simple program with the Raptor. You can see what happened here. You can see what happened with the Raptor here. If I break it down into the submodule. Now I go back to this one. Back to my program. This one. This one is the program. So basically, in the Raptor, you can break it down in the submodule. Right? So we go to the main here. Now you right click it, Can you open your router? So I think it should be better if you follow my step to work with this program. So I think I should delete everything. I can't do it from the beginning here. Again, this is a very simple program, but I want to show you how modularization works. So please open your router. You open it. So for this program here, I want to break it down. Let me see. Let me show you here. I want to break it down into 3 submodules. I have the main module here. Main. Now I want to break it down into 3 modules. So here, the first one, it is input data and input. That's why I get input. The second one, I break it down into processing. And the third one, I want to break it down into the output. I want to put it named output data. Okay, now the first thing I want to show you, this the program I want to work here is very simple program. You don't see the much benefit when you work with the modularization here because it's very simple. But later on, when you work with the project, you have a lot of work with the project. That's why you can see you have a lot of benefit when you work with the modularization. So for this program, I want to break it down into the 3 modules: input data, processing, and output data here. Now, in the router, you can work with the submodule. You can right click on the main here. You add subchart here. So when we add subchart, I put it is an input data. And I put the name. That is the name of the submodule. So what happened with the input data? Actually, for this input data, I just get the input from user. I do everything the same. I do everything the same. See, the input data, I do everything the same. That's all. That's very simple about the module, right? Now I want to do one more module with the processing. I do the same. I right click on this one. I add it to processing. Processing. What is it? It's the processing. I just double the number, right? The number I got here is my number. I just double it. So I do everything with the assignment here. The processing, right? So my answer. Number. The processing. Right? And now the last thing, I want to do the output data. Again, I click on this one, right click it, and I put it up. Output data, I just bring it out. What is my answer, right? So I just bring it out. It's output here. Okay, that is super simple program, and you can see. If you look at this program here, right? If you look at this program, I have okay. Now see. Now that is the main program, right? And now see, I break it down into input data, processing, and output. Now the first step, I want to call the input data. Right? I want to call the input data. That's why I have to use the code here. I have to use the code here. I drag and drop it, and I put here input. Now the second one, when I done with input data, I want to do everything with the processing. Again, I want to call the module here. I want to call the module here, and the name of the module here is the processing. And the last one, I want to call about the output data, right? So I see I have to be, I want to call this module here, right? So I put it out. Here. Sorry, not this one. This have to put the code here. Okay, now, so we see for this program again, you don't see any benefit when you work with the modularization. But I want to show you about the logic of the modularization here. So basically, I have the program. I break it down into 3 modules: input data, processing, and output data. Right? You can follow my you done everything. That's great. So now you see what happened here. You see about the logic of this program. What happened in this program? Now, when you execute it, when you execute program, right? It always execute from main program, right? So start here. What happened? You go to the input data here. That is the action you call the module, right? That is the action you call the module. So what happened when you call this one? It jump it to the input data. It gets the number from end user and it store it into the variable my number. That's all. When you're done with this one, when you end for the sub module here, remember you go back to the main module. Right? Remember when you're done with this one, you go back to the main module. You move to the next statement of the main module. So next statement of main module again, it call about processing. So okay, when you call about processing, it jump into the processing, execute everything in the processing. Go back to the main module and move to the next statement. So see the logic in the slide here. I want to show you. You should understand here. Whenever you call a submodule, it jump into the submodule. It execute every statement in the submodule from the first statement to the last statement, right? And when done with the last statement, remember you have to go back to the module you code the code here and you move to the next statement. Make sense? Now, when you execute program interrupter here, what happened here? I run step by step. I want to run it step by step. You can see what happened. Now see, starting with the main module, right? Go to the input data here. What happened? It jumped to the input data. Right? Execute everything in the input data, but this one is very simple. You only have one statement here. Right? That's why you see it get input from user. Right? It's number 15 here. Now what happened? When I end it, and here is the end of the module. What happened? It goes back to the main module. You see? And it moved to the next statement in the main module here, right? So again, in the main module, it call about the processing. What is it? Processing here, user double the number, and again, when you end it, move to the main module, main module, and move to the next statement here. And again, this one call out. What's my answer? Right? So exactly this program works the same with the one before. This one only show you how you break it down in the module structure in the Raster program. Right? But again, you see later on when you work with the project or huge program, you see you have a lot of benefit when you work with modularization, because see you can break it down in huge program into multiple smaller programs. Very easy for you for the debugging, troubleshooting, and identify the error. Right? Okay. Any question about this one? And I strongly recommend you open the Raptor, you follow the same with my way I work here. So it's very easy for you to understand when you work with Raptor. Any question? The same with this one here. When I work with a Python, I don't know if I have. Yeah. Later on, when we learn about the Python, you can learn about the definition of the function. But this one also, when I execute it, I go to the main. Right? What's the main? I get input from user. Right? And now see, this is the action I call it here. Rectangle is another function. And what is a rectangle? It's function that I figured out the area from the width and the length here. Right? This one is beyond the scope of this class, but I want to show you how it works with the Python. So you go from the main module, right? When you call for any submodule, it jump into the submodule, pick it out, and return value, and take it out. The same. Actually, I follow the same process. So do you have any question with the submodule in the Python? I'm sorry, in the Raptor here or not? Just let me know. Any question? Very simple with this one, right? Very simple with this one here. So now that is the way you work with the modularization. That I just want you to remember the rule when you call it here. Remember, whenever you call the submodule, it jump into the submodule, execute everything, every statement from the first to the last. When you're done with the last, remember you have to go back to the module, call it, and you move to the next statement. Yeah. Right? So basically, you can do with the submodule in the flowchart or simple code also. When you work with the flowchart, you have symbol, you have to call module in rectangle. The same with the Raptor here. You can see. That is a rectangle here when you call it. Right? In the flowchart, you have the use a rectangle with the bar across the top, right? And place the name of module you are calling inside the rectangle and draw each module separately. Remember that you have to draw each module separately with its own sentinel symbol here. So about this program here, they have the example of this program here, right? You have string name and the balance in the number format, and you got the name and balance from user, right? And print it out. ABC manufacturing, and print out address, and you print it out customer name, and also print it out the balance here. This is very simple program. In the Raptor, you can see it's very simple program. The Raptor I show it here. So that is a Raptor. It's very simple program. User get the name from user, get the balance from user, and print it out, right? Manufacturing address, and the name and balance here. So when I run it, and then let me check. Print out information about employee, right? About the manufacturing, and address, and the name, and the balance. Very simple program, right? And you can do the same. This one also you can do the same in the Python also. Then follow the same, right? You need the two input. That is the name. That is the balance here. And I explained it already, right? I explained it already for you, right? By the default, when you use the input function here, it always stores in the string format, right? In string format. And name here is the string format. That's why I do not have to convert it into the number format here. But for the balance, it is a number format, right? That's why after this one here, after I get the input, I have to convert it with the float function to convert it into the number format, right? And okay, everything here do the same. I just print it out, print out customer name, print out the balance here. And I can run this program. Name is here. Under here, see, it's print out. That is very simple program here. And they want to show you if you work with modular program, what happened here? If you work with modular program, what happened here? See, everything. Modular program is what happened here. Statement taken out of main program and put into the module have been encapsulated. That means you take some part of the main module, you encapsulate it into the another module. The purpose is that the process break it down into smaller module. Easy for you to follow up, right? And to see it here. So when you break it down, you have the main program become shorter and easier to understand. When you break it down, see, when you look on the program, it will be shorter and easier to understand. Right? Think about this program here. So we look on this program here. Very simple. I know for sure this program has the 3 modules. That's the first one I know for sure. I need to get that. The second one, I need to do everything with the bot. The third one, I need to take it down like that. Again, this is a very simple program, but at least when you look at this program, you figure it out. This have the 3 module here. Right? Everything. The first one is everything from the input data. The second one is processing, and the third one is the output data. Right? So the first benefit, when you break it down into the sub-module, the first one is the main program will become shorter and easier for you to follow, to see what is going on with this one. Right? This one very simple program, that's why you do not see much benefit, but at least you understand that you have the 3 module for this one. Right? Okay, that's the first step. That's the first benefit when you work with the modularization. The main program will be simpler and easier for you to follow. That's the first thing. Okay, and shorter and easier. The second one is that modules are reusable. What is reusable? Reusable, that means you only need to code it once only. Code it once, but later on you can use it again, and again. It's not only in the one single program, but later on when you work with real programming, let's see, you can use that module. You can plug in any other program. So you see, you only need to program once only, but you can use it again and again and again. Make sense? Okay, so I can do the same here. I can do the same with my program here. You can see what happens. I can do the same with I can modify the same with my program. And so see what happened here. If I do it one more, I just call it one more. I want to call it one more. I want to call input data again. Okay, and I want to call it one more time with the processing. I can do it. Do it one more with the output data. Okay. So what happened here? See, for the input data, I code it only one time, right? This one also, I code it only one time. This one also, I code it one time. But again, I can code it whatever I want, many times I want. Right? That's why it's reusable here. So I run it here. The first time, the number is number 10, that O is the number 20. Right? That's the first one. Now I do one more time, 15 here, and the number here. Okay, so we see that a huge benefit when you work with the module. You only code it once only, but again you can reuse it again and again. Not only in your program, but you can use it in another program. So you can think about it's a container, encapsulate, and you can plug it out in any program you use. Okay, and when statement contribute to the same job, you get the greater functional cohesion here. Later on, we see you have to see huge benefit of break it down here. Now, see with this program here, when I work with the modular program for this one very simple program. Okay? That's why I see I work with the modular program. Now, if you look at this program, here, you can see when you compare to the other one here, where the other one. Yeah, this one. Now see this one here. I need to get the name and the balance, and I have to print it out everything information here. Now I can encapsulate it. I can encapsulate this one, everything with this one, with the display address information. Right? So when I move to this one here, right? So see, I enter the name, balance. You see, I have the display info. What is it? Display info. I have everything to show it up attractive. So you see, if you look on this program, here, I know that I need to the name and balance and display info, or I can even modify this program. Again, I have output data. I just copy this two guy here. And just copy two guy. Paste it here. Again, for this one, I have output data. Output data. I copy everything. This one. Got it. Where I need input data, the first one I need for displaying direct information. Okay, so see, if you look on this program here, I can do comparison here. I can do the comparison here. Okay, you see this. I'm gonna go back to this one. But again, I will just show you here, right? You see, I have input data. What is the input data? I get the name and balance. Right? So if you look on this program here, you have the three submodules: input data, get the name and balance. Right? Now display address information. What is it? Print out information here. And the last one, output data here. Right? So we see when you run by that, run it step by step here. Go first input data. What is it? Name, right? There you go. And you have the 4500 here. Right? When you're done with this one, okay. When you're done with the last statement, go back to the main module, move to the next statement here. Display address information. What is it? Do everything inside. Right? Done with this one. Done with this one. Done with this one. Go back to main module. Go to the output data. Right? What's the name? What's the balance? That's all. Right? So you see, if you break it down into the submodule, you have something here. The first one, the main module becomes simpler and easier to read, to understand. Right? And you can reuse this again and again and again. Right? That's the sum of the benefit when you work with the modularization. Any question? Hello?
None for me.
Question.
Yes, what is your question? No question or you have a question?
No.
Okay. The same with the submodule here. When I work with the Python, right? I execute the main, and in that main, I have the two. Sorry, in the main, I have the function here. I have defined the main. Main, I get the name and the balance, and I here for this process here. It's the main program. You see what happened here. I call the function. Right? Actually, this is so what happened? You know that execute everything from the first statement to last statement, right? The first one, move to this one. When the call here, actually it jump me to this one. It jump me to this one because the name here, right? And execute everything from the first statement to last statement. When you're done, you go back to the one who called you. Okay, read it out. What's the name? What's the balance? Right? That's the same when you follow the process with the submodule in the Python here. So you can see when I run it here, it follows the same. Execute everything in the main first, right? This one and then and then 40 here, 500 here. Now that is the second one. The second one calls to this one. The third one calls this one. Read it out. Here, read it out. Read it out. Read it out and read it out. Read it out. Go back to my module. Read it out. That's the name and total. Make sense? Okay. Okay, so we see you have huge benefit when we break it down with modularization. Easier to read, easier to design, code, and test program one module at a time. So if you have anything going wrong with any module, you just go to specific module, right? And you locate the error and fix it. It's easier for you to design code and test program one module at a time. Okay, and also you have different program module can be designed and code by different programmers. You break it down into smaller module and you assign each team with specific module here. So they can do it parallel. They can do parallel at the same time instead of everyone at the same time. And a single module may be used more than one place in the program, and even in other programs, right? So you can reuse it, right? And module can perform the common programming tasks can be used in more than one program. Okay, now you have the process of declaring variable and constant within the module. Right? So basically, if you want to declare the variable and constant within the module, you have to put it inside the module. Say sometimes they call it the local variable. Local variable, that means it only used inside the module only. You cannot use the outside of the module. If you want to use the outside of the module, later on we learn about global variable. Global variable, that means you can use it in any program. But in the local variable, you only able to use it inside the module. So basically, within the module here, you place any statement within module. You have the input processing and output statement, variable and constant declaration. So the same with the program here. Before you work with any module, you have to declare variable. Before you use that, you have to declare variable using it. Variable and constant declare in module are usable only within the module because they are local variable, visible and in scope they call the local here. So think about this one here. Think about this program. I can show you what is the local variable here. See why is it called the local variable. Okay. Now you can see about this program. You can see about this program here. I have the main program here. When you done main program, I call for the display function. What is the display function? I got act here. I got act and print it out. Act again. Act equal act plus 10. And you can see what happened with this one. You can see what happened with this one. With this program. When I run it, when I run it, now enter the number. Now I got the syntax error. I got the syntax error. The reason I got the syntax error because here, you can see for this one here. The reason I got the syntax here it is a local variable. Local variable inside the function display only. Right? But later on here, in the main program, I call act here. Not understand what's that. Because act here is a local variable already can be used inside the display function only. Make sense? Okay, that's the local variable here. Okay, and sometimes you have to work with the global variable, right? Global variable and function here. And in the global variable and constant, you have to declare at the program level at the beginning of the main program. That wise you can access it to from any module, right? And declare at the programming level, visible to and visible in all the module called by program. And many programmers avoid global variable to minimize error here because sometimes it's very confusing. Later on we learn about that one. Okay, so think about this one here, right? Think about this program here. For this program, you have name and balance. They are global variable in the main program here. But for this one here, for the display address here, everything here you have to define it with a local variable. They are addressed as local variable. Okay, now we move to the understanding the most common composition of the mainline logic. So again, I have to highlight that this is very important in the case you work with debugging exercise. You have to understand the mainline logic here because I believe that from the chapter number 2, I'm not sure this week you have the debugging exercise or not. I'm not really sure. Okay. So again, I just want you to pay attention to this definition here about the mainline logic because from now on you use it a lot in the case you work in debugging exercise because they follow the same rule with the mainline logic. So the mainline logic of almost every raw CPU computer program follows the general structure here. The first one, you have to declare for the global variable and constant. That is global, right? That means at the beginning, it can be accessed by any module here. The first thing. The second one, it can use a housekeeping task here. That is that you have to must perform at the beginning of program to get ready for the rest of the program. Later on, I explain what is it. And you have the detailed loop task, do the core work of program, and also you have the end of job task here. Step you have to take the end of program to finish application. So basically, you have to see you have the declaration, you have the housekeeping, you have detailed loop, and you have end of job task here. So basically, for the mainline logic, you remember about the 4 steps here. The first one, declaration of global. The second one is the housekeeping task here. The third one is the detailed loop, and the fourth one is end of job here. Now I explain it to you once by one. What are they? So if you look into the flow chart, you can see that is a mainline logic program. You have a declaration about the global variable. Housekeeping is a very important step. You need to get it in order to get ready to the program. In order to go with the loop, and here is the example, specific example to understand what is housekeeping here, right? So again, when you go to housekeeping, you have the condition to check the loop. So whenever you do the correct, so whenever the condition is true, you keep doing it again and again with the detail loop here. But if not true, you go to exit program, you go to the end of job. And so we have 4 steps here: declaration, right? Housekeeping, detail loop, and job. Basically, that is the mainline logic for every program. It should follow. It should follow it. The same when you work with the pseudocode here, you have declaration, housekeeping, right, and detail loop at the end of job. Now we go with. I believe that we have some very basic info. Very simple example about the mainline logic here. Now, if you look on this program, that is process. That is a process. You want to input information about multiple employees, right? Each of them, they have a name and they have a gross and deduction, and you have figured out what the net income. You do it for again for multiple employees, right? Until you enter the sentinel value to exit it here. Now, about this program, what happened about this program here? You can translate it. So basically, this program works with the modularization process here. Now, you do everything with the declaration, right? You need a name, a string format. You need a gross, you need a deduct, you need a net income, and the rate here. You can see something about this one here. You can think about the rate here. They are in capitalized. That means it's a constant. They do the constant here, 0.25. And this one also constant here with I report heading, and they are all of they are constant here, and they are all constant. Now, if you look on the flow chart, and if you look on the pseudocode here, they follow the same. They always follow the same 4 steps here, right? The first one, declaration. The second one, housekeeping. The third one, detail loop, and the fourth one, and job here. The same with the pseudocode here. See, you have declaration here, right? You have housekeeping, you have detail loop, and you have end job here. But you should understand about the structure of this one. They break it down into the modularization. This program, they break it down into the modularization here. And so what happened here? When you call about housekeeping here, this is the action when you call for the module name housekeeping. Huh? So when you call the housekeeping, you have to define the action. You have to define every statement inside the housekeeping. What is it? Actually, this housekeeping is that print it out, output, reporting, heading. What is it? Payroll report here. Right? What is it? I'll put the column heading here. What is it? Name right here. But again, this is a very important step in the case of the housekeeping here. That is the most important step in the housekeeping here. You need to get the name of the first employee in the list. You need to get the name of the first employee in the list. Why do you need it? Because later on you see, when you go to the loop, you have the condition here to check. You have the condition here to check. If you do not get the name here, you have no way to compare. You have no way to check it. You got the syntax error. You got the syntax error for this one. Right? So this is that is very important here. Input the name. What is the name? You see, if name is not keep doing it. It's not keep doing it. Right? Keep doing it until you enter to exit program. And that's why the housekeeping here is very important step. You need to get it in order to get ready for the loop to execute it. Right? And later on I give you the example why it's very important. Now you see, if you look on this program, you call the housekeeping, you get the name, right? Now you check if the name is not you go to detail loop here. Again, you call about the module. What's the detail loop? Detail loop here. You get the gross, and you figure out what is deduct, and you figure out what's the net, and you print it out here. You print it out here. Now, that is when you're done with one employee. Right? But if you want to move on to the next employee, again, you need to get the new name of the next employee here. Name here is not the same with name here. Name here only for the first employee, but name here is for next employee in order to keep doing it again and again. Right? And the same you can see with the single code here. Housekeeping, that's the action you call for the function. What is it? Get everything. That is very important step here. What's the name? When you're done with the housekeeping, go back. You check the condition. If the name is not do it with the detail loop here. Detail loop here again, call about detail loop. What is it? And the gross and the gross, get the gross, figure out the deduct, net, and print it out, name, gross, deduct, and see, you have to move on to the next employee. Now, I show you by the example when you work with this one. Show you with I show you with the program. So you can see why it's so important. Okay, you see that's the program, right? Now, if you look on in the slide here, I do exactly the same, follow the same program. I follow the same with this one, right? Yeah, I got declaration with some of the variable here. Look at this one. I have red, I have green here. Here is x. That is x here. Now, everything here is just print it out here. Now, you see, what's the housekeeping? Housekeeping here. The important process is housekeeping. I get the name of the first employee. I get the name of first employee here. So what happens when I done with the name of first employee? I go to the loop. I check the loop here. If the name equal to quit here, that means I exit the loop. And if not, I keep doing it. It's a detail loop here. What detail loop? I get the gross, I get the red, I get the net. Now Again, in the loop, it's very important here. If I want to move on to that employee, I need to get a new name. And when I get the new name, I go back to the loop, I check it. If the name is X or not. If not, keep doing it. Right? So see, when I run program here, you can see what happened with my program. When I run my program here, what happened with my program? I run it on I run it here. Now see, that is very important. That is very important here in the housekeeping, because you know that housekeeping is a step you get ready for the body of the loop. Now I put it here, David. So see, when I have the David here, what happened? When I get the David, right? You see what happened when you David here. I have entered the 4500. So done with next one. I want to move on to the next one. Check here. And then now I move on. I want to see. I want to exit it. I put X. So what happened? X. It's the same with the condition here. The X is the loop, right? That's why you stop the program. Make sense? I think it's quite confusing now, but I hope that by doing it again and again, you understand the logic. Any question with this one or anything you need me to explain it again, just let me know. Now, what happened here? Let me see. Let me show you what happened. If I delete this one, what do you think? If I delete this program, now let me do it again. It's housekeeping here. I can do, why I cannot? Like that. Okay. See, if I delete this one, what do you think? What happened? If I delete this, yeah, think about this one. If I delete this one, if I delete this one, what happens? What do you think? What happened with this program? If I delete this one, guess it. You can guess it. If I delete,
you can't enter any name.
yes, you can enter any name. Yes, right. But what will happen next? What do you think? What will happen next here? Now see. If you delete this one, right? Program execute everything here perfectly. Execute here, everything perfectly. Now we go back to this one. You check your condition. If the name equal to quick or not, what's the name? You have no value of the name. You have syntax error here. Right? You have no value of the name. You have the syntax error here.
Oh, yeah, so it's gonna crash the program.
Yes, because the thing here, it not understand what is name. That's why the housekeeping here very important. You have to be get ready for the loop to execute. If you do not have the name here, you have no way to compare it. You have no name to compare it. That's why you have to crash it. You see what happened here. You see what happened with my program. If I delete it, where? Now see what happened with my program if I delete it here, and I run it. Yeah, see, it tell me variable name not found. Right? And now, if you look into my program in the Python, I think the Python will be way easier for you to follow. Now, see, that is the Python here. That is my Python program, right? So everything here, you can see, but everything here it is a global variable, and I need anything in declaration. Housekeeping here, right? I do the same. I create here, right? Now that is very important step here. I get the name. I get the name because I need to get the name in order to go to look here. Because see, later on here, I have the condition to check if name equal to x or not. Right? See, if you do not get this one here, what happened? See, you can see what happened by that.
Yeah.
Yeah, you have the syntax error. What's the name? What the heck is this? Doesn't understand what's the name. Right? That's why in the housekeeping, you just remember the housekeeping here. It's very important step. You need to get the value in order to go to the loop. Right? Because in the loop, remember that the loop, you only have the condition to check. In the Python here, if true, keep doing it. If not true, exit the loop. Right? That's why if you want to execute the loop, you only have the condition to check. That's something you have to remember. You only need the condition to check. If true, keep doing it. If not true, exit the loop. Right? So you need the condition to check here. In that case, is the name equal to x or not. So that in that case, you need to get the name before the loop, outside the loop, right? And you have to do it with the housekeeping in the mainline logic here. That's why you need to do it in the housekeeping, right? That's why you need to do it with the housekeeping here. So see what happened if I execute my program in the Python. Now you see, and the name here. That is the first one, right? The first one I did it. I did it here. Now I enter it and draw 4500. Do it. Now see, okay, it's very important step in the body of the loop. In the body of the loop, when you've done everything with one employee, if you want to move on to the next employee, you need to get a new name of the next employee. Right? Because what happened here with the loop? What happened with the loop here? You can see what happened with the loop. You done everything. You go back to check. 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 Right? That's why you need to get the new name of employee to check it. It here his real name or otherwise keep doing it. Now see what happened here. You can see what happened if I delete this one. What do you think? What do you think if I delete this one? What happened with my program? Yes,
you won't be able to break out.
yes, keep doing the same. Now what happened here? See, if I enter the David here, you can see what happened. If I enter the David here. So now you have slot in the memory with the name. The name of the slot here is the name. And it's store David here. So see, when you go to the loop, name, what is the name? David. It's not I. Do it, right? Print it out. Now go back. What's the name? The same. It's always David. It's always David here, right? It's always David. Never ever change. That's why I keep doing it again and again and again. It's endless looping. That is endless looping. Make sense? Now I execute it. You can see what happened. Execute it. You can see what happens. This one. Right? Now, David. Right? 4500. 5000. Now, again, you see, do it again. Again, forever. Because the name always stay with the David. Now, one done with David, print it out name, right? Be that net. Come back, name David again. It's not I here. Do it again, forever. That's why. Now, something you have to remember. Housekeeping. You need to take action to get the initial value outside the loop, before the loop. That's very important about housekeeping, right? And also, in the body of the loop, you have the action to change the value of the value who control the loop here. So in this program here, name is a variable who controls the loop, right? So it keeps comparing until it's here. The name is the one who controls the loop. So inside the body of the loop, you need to have action to change the value of the variable who controls the loop. for each iteration of the loop, otherwise it will be anything. Right? That's why I see. That's why I have to do with action here. I have to do with action here. I need to get name. But remember about the name here. Name here is the name of the next employee. Keep doing it, keep doing it, keep doing it. Now, so we see. When I run it again, now I modify already, right? So now, David. 4500. Now see, every time you have to add the name. Name here is the next employee. And you have the option to exit here. If you enter X, you go back to check here. Name is X, you exit. Make sense? Okay, and the same with the router also. You follow the same with the router. So follow the same with the router also. Right? You see, that is housekeeping here. I have to put this why I that is the most important step in the housekeeping. I need to get the name in order to go to the loop, because in the loop I have the condition here to check. Now, when you go to the detail loop here, again, very important. Details loop here. I need to get the action to get the new value of the variable who controls the loop. That's the name here. Otherwise, it is ending. Make sense? Any question with this one? Also, online student, do you have any question?
No.
Okay, that's great.
Not for me either.
Okay. So again, take a short break for 5 minutes and we come back. Okay, so you can see my program in the Python. You can see I should break it down into 4 portions here. The first one is a declaration. The second one, housekeeping. See, that is housekeeping here. The most important thing is housekeeping here. You need to get the name of the first employee in order to go to the main body of the loop here. You have a condition to check. That's why it's very, very, very important step. Now, the third one, the main body of the loop. Remember that in the main body of the loop, you only have the condition here to check. If the name is not equal to, what is it? X here, right? If the name is not equal to X, you have to get the gross. You need to figure it out what to deduct. You need to figure it out what's the net, and you print it out. Name, gross, deduct, and net here. Now, okay, this is a very, very important concept. Step here. You need to get a new name of employee in order to run this loop again. Otherwise, so you have the four step declaration. Housekeeping and main body loop. And the end of job here is very, very simple. End of job is just something you just finish the job. End line, what is the end line? Just down end of people. But again, just remember about you have the 4 step in the main line logic. Declaration, housekeeping, main body loop, and end of job here. But the 2 most important is the housekeeping and main body loop. Is the housekeeping. Remember, you always need the value to get the value of the variable who control the loop here. Because here in the loop you only have condition to check. That's why you need to get it before the loop, outside the loop, in order to go to the loop here. And the second thing very important is that inside the body of the loop, you only need to action to get the value of the variable who controls the loop. Make sense? Okay. That is 2 very important things you have to remember about the housekeeping and the main body loop. And you can follow the same. You can follow the same with the router also. It's very important. The first step here is housekeeping. You need to get the value of the variable who controls the loop, before the loop and outside the loop. You see, you need to get it outside the loop here, before the loop. That's the first thing. The second thing is that in the detail loop, always have action to get the new value of the variable who controls the loop here. Because you see, name here is the one who controls the loop. That's why in the detail loop here, you always have action to change. And normally you do at the end of the body of the loop. Make sense? Okay. remember some of the very basic rules. You have to use it again and again and again in the debugging exercise or in the process. So you can see now you have the sum of benefit when you work with the modularization, right? When you work the modulation, you have the sum of the benefit. Right? You see, you break it down, it's way easier for you to follow. Right? Everything here, declaration. This is housekeeping, this is the main body, and this is end of job here. So the same with this one here. When you look into the main body, see declaration here, right? Housekeeping here, body is look here, and end of job here. And for each of them, again, you can go to the what is housekeeping, what's the detail loop, what's end of job here. You can see. Actually, I modify a lot of slides to include everything. My work with the Python and the other here. I hope you got the best picture of this one. Now, so you know that you have benefits when you work with the modularization, right? And you can do the modularization in the planning process, right? Using the flowchart or pseudocode, right? So in the case of the planning, it should be better if you work with the hierarchy chart here, because when you work with the hierarchy chart, you see what is the connection, what is the relation between the module, right? So you look on this one, you know that for the program you have one main program. Is that you break it down into the 3 modules: housekeeping, detail loop, and end of job. And again, later on, if you have the complicated program, you can break it down furthermore. For each module, you can break it down into sub-module, multiple sub-modules, right? If you look on this program here, sorry, if you look on this diagram here, okay, you break it down furthermore. Housekeeping, what is it? Get order. Or detail loop, what is it? Process order, get order, and so on. You can furthermore, you can break it down furthermore. It is a complicated program. Totally up to you, and you are totally flexible with that. Any question? Okay. Now, some of the feature for good programming design. The first one, use programming comment where appropriate. It's very helpful. If you have the huge program, it's very helpful in the case you are the one who program. Right? It's easy for you to follow up what is going on with your program. Right?
I have a question.
Yes.
So in Raptor, when I know we have to do comments in there, and what do you suggest is the best way to do comments in Raptor? Because I found it kind of difficult because there's no dedicated
I know
comments.
in the Raptor, I only have one suggestion: is that you should do at least header comment only. Don't do anything with the inline comment, otherwise very confusing in the Raptor. Right? Just do with the header comment only. So if you do the header comment with the Raptor, you go to the program, right? You go to the program in the Raptor. Right? Yeah. Right? You just right click on the start and you click the comment here.
Oh, okay. Cool. Yeah, I didn't know about that. Thank you.
So again, for the Raptor, I only suggest you to do the header comment, but not inline comment, as a white very confusing. But in any other programming language or Python, you should do the inline comment also. I explain what is a header comment and what is a inline comment here. So now use the program a comment where appropriate. Right? Identifier that means variable name. You should choose it carefully and choose a meaningful name. Instead of X, Y, Z or anything or whatever, right? Should use the price or meaningful name here. Try to design clear statement within your program and module. Right? Clear prompt and the equal input. I will explain what is a prompt and what is a equal input later. And continue to maintain the good programming habit and you develop the programming skill here. Now, the first thing about the comment, I think the comment here. Program comment here. What is the comment? Comment is written explanation of programming statement here. It's not part of the programming logic. So basically, from the computer point of view, have no benefit in the comment. It only benefit to the programmer, right? If you are the programmer, you can see what is going on in the code here. But from the computer point of view, have no benefit. So we see with this program here, when I delete this one, right? When I delete this one, or I delete this one, or I delete this one, when I execute it, it works exactly the same. It have no benefit from the computer point of view. But you see, if I am the programmer, right? If I am the programmer, I can see what is going on with my program, right? Yeah, this step here, the declaration, this one is housekeeping, and so on. Right? Okay. But remember, it only benefit to the programmer, no benefit from the computer point of view. When we execute exactly the same. Right? And now for the commands in the interrupter, right? User right click it and they put it. And remember, interrupter, I only suggest you to do with the header command only, but not inline command. So in the case of the Python, you should do the inline command, right? You can do with the inline command here. You can browse get name from. Sorry. Okay, that is inline command. That is inline command. Or also, you should also do work with the header command. Is the header command here. Ram now for employee before we put something here. It's up to you. It's up to you. That is header command. But also, you can put the inline command also. Inline command that it's really helpful in the case you want to work with debugging or you want to follow up with your coding. Right? Okay. Again, remember that any command here have no benefit from the computer for only benefit to you. You are the one who coded. You are the one who programmed it. Very helpful. Right? Think about a huge program here, and someone hand over to you very complicated program. It's very useful if you look on the header command and inline command to see what is going on with the program. Right? Okay. So now, see, it's not part of a programming language logic, right? Because even it have or don't have exactly they will execute the same. And serve as internal documentation for program for you, very useful for you, right? And syntax is differ among programming language, right? Because when you convert from pseudocode or flowchart to the Python to the Java, they are not the same. Each of them they have specific syntax, and you should understand about the syntax, right? Flowchart, we should use annotation symbol to hold information that expand what is stored within another flowchart symbol. That is the case you use a command here. That is the case you use a command. So here's some example of declaration. You see, you have defined the variable square feet here, and you tell what is it. Square feet is estimate provided by the seller of the property, and so on. Right? And so on with the symbol. And also in the flowchart or interrupter, you can have put some comment here to tell what's going on in this one. Choosing identifier or variable name is very important again. Give variable or constant name that is now. Normally use a now here, right? Price or income tax or whatever it is. Right? And normally you give the module or identifier that is a verb, because that is actually called them, right? That is called them here. Use meaningful name, right? You pronounce a serial name, and so on. Avoid digit in the name. General guidelines here. Use your system, your language allows separate words among long and multi-word variable. Now think about this one here. Design clear statement, avoid confusing break line, use a temporary variable to clarify long statement here. Right? Make sure your meaning is clear. Do not combine multiple statements online. Right? Now, sometimes you have to use a temporary variable. Right? What is a temporary variable? It's a work variable. It's not used for input or output. It's not used for input or output. That's why it's named a temporary only. Right? That is a working variable that used during the program execution, right? So think about this one here. Think about this one here, right? I want to figure out the sale commission. Right? I know that sale commission it can be figured out from the sale price, right? From the sale price, right? So you see this one here, I can do it. This one work also. This one work also. This one work also. But it's very confusing. It's very confusing here. So what is it? Actually, this one is this here. You have to figure out what is the sale price, right? And from that, you come with the commission rate. You got the sale commission here, right? The sale commission here. But I can use temporary variable here, right? I can use the temporary variable. So discount price here, what is it? Discount price actually it's original price times discount rate, right? So that is a temporary. Again, I can use another one temporary price variable here. Is a sale price. What's the sale price? Original price minus discount price here, right? And of course, this one here, sale commission is a sale price times commission price here. So see, if I use discount price and the sale price, they are temporary variable. They are temporary variable. They are not input. They are not input. Actually, for this one, I only need original price, discount rate, and commission rate are input here. And the output here is the sale commission here, right? So discount price here and sale price, they are not input or output variable. They are temporary variable. But it makes way better for me to talk about. Okay. So if you have a long statement here, you can break it down into multiple lines and you can use a temporary variable. Make sense? Okay, so see, I can understand here. Discount price, for sure, it is original price times discount rate. And so, or sale price is original price minus discount price, and so on. Make sense? Now, writing clear prompt and equal input, that is also very important here. So back then, if you look at the program here, if you look at the program, if you look at this program, yeah. Right. Okay. So this, I believe that this is program you do it in the homework, right? And security work. So we have the 20 here, and the 10 here, and area rectangle here. It's kind of work, right? Work here, but it should be better if you include in the equal input here. So equal input that means you include the value of the variable from input somehow in the output here. Now, what happens if I modify my program? I modify my program here. This one. So we see what happened here. If I run it, I have 20 here, and I have 15 here, and from the program here, right? It way better for me, right? The area of rectangle with the length of what? Take it out value from input here. So see what happens if I run my program here. I put 20 here and I put 15 here. So see what happened here. The area of the let me I cannot larger. So see what happened with my program here. If I add the number 20 here and add the number 15 here, this is the process I work with the equal input here. Equal input here. Equal input here. What happened? It means now here area of the rectangle with the length of what is the length? It take it out 20 from the variable here. What is the width? It take it out number 15 from variable here. And it show it up in the output. It will make more sense to the end user here, right? See, if I run it again, you see what happened if I run it again. And here, 15 here. You see, if you compare this one here, the area of the rectangle is 200, and this one here, the area of rectangle with the length of 20, right? And the width of 15 here. It much way better for the end result. Right? That is the process of the equal input. So the equal input is the process you take the value from the input and take it out in the output somewhere in the output here. Right? Is that good? You take it out here. Make sense? Any question about this one? Okay. So I expect that from now on, whenever you work with the Raptor or Python, you should use the equal input here. It is a good behavior when you work with the program here. Right, so that is a kind of the equal input here, and you can do the same. You can do the same when you work with Python here, right? So think about this one here. Enter graph. So I can do this one here, right? So think about this one when I run it. When I run it, it's way better for me, right? So think about and David here. So see, what happened? Oh, I had to put that, I believe, it's been a long time. So I run it here, right? David here. Yeah, so see, way better, right? Now enter gross for David because I take it down name here. That's the David, huh? And it do it again. Now I do it way better for the end here. So now enter the name. I have to check here. See, enter gross project. Enter gross project here. That is a process of equal input. Right? I take it out. And take it out is a problem here to make way better for end user to follow up with the what is going on with the program. Okay. Make sense? Okay. How is it? Also, in the problem, right? That you see is a problem here. Always try to use a meaningful problem. And you see, if you translate this one here, if you translate this one, you know for sure that you need to declare and you need to get the name and balance here. And the same in this one here, you need to get the process to get the name and balance here. But it should be better if you use a prompt here to tell, please enter customer name, and please enter balance to way better for the user, for the user here. So try to use a clear prompt as you go input in your program from now on. I think that's all for today. And on Wednesday, I will go over to some of the Python and some of the case diagram. And if you have time, we can go over a little bit with the chapter 3 because I believe that Monday is Labor Day. We do not have class, right? So I have to go a little bit with the module 3 also. Okay. So do you have any question, guys? Again, I guess I just want to highlight again that this chapter is very important for safety. You have to understand about the mainline logic because from now on you have to work a lot with the mainline logic. Right? That's why you have to understand. You have to understand the logic of declaration. You have to understand the logic of the housekeeping of the main body loop, right? And also and the job here. But two of them is very important: housekeeping and the main body of the loop. In the housekeeping, you need to get the value of the variable who controls the loop outside and before the loop. And inside the body of the loop, at the end of the loop, you need to actually to get the new value of the variable who controls the loop. Otherwise, we will end this loop. Right? Okay. So I hope that's all for today, and I think that's all for today. And for anything is not clear, please come back to me anytime. You can email me, inbox me, or join my office hour here. But if you are not clear about anything on this slide, I recommend you to watch again the record video and upload with an announcement later. And again, even after the record video, you are not clear, come back to me anytime. Okay, because you have to use it again and again with the main or with the main line logic in this class. Okay. Bye you guys. Bye bye. Oh, hold on. Let me check the attendance here. Yeah. What is the Caleb, are you here? John, are you here?
Did you say Mike?
You are Caleb?
Yeah.
Sorry. Yes. John, are you here?
Here.
Okay. Gabriel, are you here? Gabriel, are you here? Matt, are you here?
Here.
Jeremy, are you here?
Here.
Luke, are you here?
Yeah, here.
Grant, are you here? Grant, what is that? He quit. Saul, are you here?
I'm here.
And Ju, are you here? How to pronounce the name? Jihi. Hello? Ju, Jihi, are you here? Okay, so I see you guys on Wednesday. Bye bye.